In this video, we will discuss how to solve logarithms using log tables or tables of logarithms. Now, before we go deep into this discussion, we need to keep a few things in mind. First, the one commonly used today is based on common logarithms or base 10 logarithms, which were compiled by an English mathematician called Henry Briggs in the year 1617. That was way before the use of calculators and computers became popular. So the log table actually lists values of the function log to the base 10 of a certain number x, which is in a certain range and at a particular precision. So now let's get into our discussion of using log tables to solve logarithm problems. First, we need to know that the common logarithm of a number can be split into two parts, an integer part and then a fractional part. The integer part is called the characteristic and the fractional part is called the mantissa. So for example, if we were to find the log to the base 10 of 256 using a calculator, we will get 2.4082 approximately. The 2 or the integer part is called the characteristic, and the decimal fraction part, 0.4082, is called the mantissa. We can express this same problem using a power of 10 multiplied by a certain number. So we can express the common logarithm of 256 in a form log to the base 10 into brackets 100 or 10 raised to the power 2 times 2.56. Now, if you remember, this format is the standard form format. Now, if we use the product rule of logarithms to break this down, we will get log to the base 10 of 100 plus log to the base 10 of 2.56, which eventually results in 2 plus log to the base 10 of 2.56. Now, it is easy to find this number 2. How? If we express the number in standard form and then find the logarithm of that expression in standard form, we will get log to the base 10 of 10 raised to the power 2. So the 2 here is the exponent of the number 10. So it is easy to find this one. Therefore, the log table does not show us how to find this number or characteristic. Rather, it focuses on finding the mantissa. So let's see how this is done. Again, let's remember that log to the base 10 of the number 256 is equal to the characteristic plus the mantissa part. Now let's see how to use the log table to find the mantissa. So the log table has rows on the left column. The numbers start from 10 upwards. And in the columns, we have two main columns, the 0 to 9 column and mean difference column, which helps us to find the mantissa. In our question, we do not have a fourth digit. Therefore, we can replace it with 0 or just leave it like that. So to find the common log of the number 256 using the log table, we will scan the rows to find the first two digits of the number, that is 25. Now, we will look up from the 6th column, that is the third digit in the number. Where they intersect is the number we are looking for. So in this case, they intersect at 4082. Now, because there is no fourth digit, we will not look up any number from the mean difference column. So what is the result of looking up the mantissa from the log table? We just found that the mantissa, according to the table, is 4082. So all we have to do is to combine it or join it with the characteristic we found earlier above, and then we will get 2.4082 as the answer. In reverse, we will also learn how to find the antilog of the number we just found, 2.4082, using the antilog table. Quickly, we will just use the calculator to find what the answer would be. So finding the antilog of the number 2.402 gives us approximately 256. Again, let's remember that the 2 represents the characteristic or the power of the number 10, and the decimal part, 0.4082, is the mantissa. So in principle, the antilog of the number 2.4082 is the antilog of the number 2 times the antilog of the number 0.4082. It is easy to find the antilog of the number 2. It is simply 10 raised to the power the number, that is 100. But we will find the antilog of the mantissa using the log table. So let's learn how this is done. Again, we are finding the antilog of the mantissa portion of the number 2.4082 using the antilog table. The first two numbers will help us to search for the mantissa from the row. So here we will look for 0.40. Looking at the third digit, we have the number 8. So we will have to look up the 8th column. This intersects at the number 2559. And the fourth digit takes us to the mean difference column, the second column. And this gives us 1. So we will add the 1 to the number 2559 and we will get 2560. Now let's remember that we expressed the logarithm of 256 in standard form first before we found the Mantissa part. So we will put this same number in standard form again. So we will place the decimal right after the first significant digit 2 and then we'll multiply it by 10 raised to the power 2, which is the antilog of the number 2 we found without using the antilog table. Now, if you multiply through, you will now get the original number 256. So here we have demonstrated how to find the logarithm of the number 256 and the antilog of the number 2.4082 using the log table and the antilog table. Now let's try solving this question. If the log to the base 10 of 0.00256 is equal to x, find x using a log table. Also find the antilog of x using an antilog table. Now this question will demonstrate how to find the logarithm of certain numbers when the characteristic is a negative number. So the first step is to convert the number 0.00256 to standard form. And that gives us 2.56 times 10 raised to the power minus 3. So here we can identify the minus 3 as the characteristic in the step 2. In the step 3, we will find the logarithm to the base 10 of the number 2.56. That is the Mantissa part using the log table. Ignoring the decimal point, the first 2 digits is 25. So we will go to the row and look for the number 25. Then we will look for the third digit, that is the number 6. So we look in the column 6. So the column 6 and the row 25 leads us to the number 4082. Since there is no fourth digit, we will not bother with the mean difference column. That means that the Mantissa part is 4082. In step 4, we will now join or add the characteristic, that is the minus 3, to the Mantissa part. Technically, if you were to use a calculator to solve for a question log to the base 10 of 0.00256, you will get minus 2.5918. And this is simply an addition of the characteristic minus 3 and the Mantissa 0.4082. But in this example, we are not going to add them together. We want to keep the Mantissa separate and the characteristic separate so that just by visually looking at the number, you can see that the characteristic is minus 3. So we just place a bar above the 3 and then join the Mantissa part 0.4082. There are several advantages of leaving the answer in this format, especially when we use the log table. If we leave the number in this format, it helps us to use the log tables to find the log and the antilog of the numbers. So in this example, the log to the base 10 of the number 0.00256 is minus 3 plus 0.4082, where the 3 here is the characteristic, or minus 3. From this answer, we can also find the antilog of the number x using the antilog table. So again, we'll go to the antilog table and locate the first 2 digits, that is 0.40. We'll also locate the column 8. The column 8 and the row 0.40 leads us to the number 2559. There is a 4 digit 2, and so we'll have to look at the mean difference column 2. And that also takes us to the number 1. So we'll just add 1 to 2559 to get 2560. So now we will express our findings in standard form. So we will insert a decimal point after the first significant figure to make 2.560. Then we will multiply it by 10 raised to the power, the characteristic, or minus 3. When we do so, we will get 0.00256, the original number from which we found the log in the first place. There are a few key takeaways we can get from using the log table to find the log and the antilog of numbers. First, in general, if log to the base 10 of x can be expressed as an integer part plus a decimal part, in other words, the characteristic plus the Mantissa part, then it implies that log to the base 10 of x can be found by joining the characteristic with the Mantissa. So you write the characteristic and the decimal point, then the Mantissa. Also, x will be equal to the antilog of the Mantissa times 10 raised to the power the characteristic. We will see how this applies in the following examples.